screen. Okay. Can you see everything?
Yes.
Okay. So let's start. Hello, everyone. My name is Artem Lebedev. I'm working in big IT companies for the last 10 years. And today I will talk about cloud computing and serverless technologies. I will talk about how these tools can be useful. This presentation will be useful for those who started IT career recently and would like to know more about different aspects of working with the clouds. So let's start first with the definition of cloud computing. Cloud computing is the delivery of computing services, including servers, storages, databases, software over the internet to offer faster innovation, flexible resources, and economies of scale. Instead of owning and maintaining physical data centers and servers, companies can rent computing resources on as needed basis from the cloud providers. And the most popular platforms here are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. So let's check the most remarkable features and services of each provider. First in the list, Amazon Web Service, the world's most popular cloud platform that has over 50% of global public cloud share. It has customers in 190 countries and offer over 200 cloud services and products. And the most remarkable services and products here are Amazon Elastic Compute Cloud service that provides scalable virtual computing power in the cloud. It allows users to rent virtual machines known as instances to run applications, host websites, or perform computational tasks without needing to invest in physical hardware. The service is called Elastic because it allows you to easily scale your computing capacity up or down based on your needs. Next one is Relational Database Service. Is a managed service that simplifies setup, operation, and scaling of relational databases in the cloud. It automates tasks like hardware provisioning, database setup, patching, backups, and scaling. It allows users to focus on their applications rather than maintaining and managing the underlying database infrastructure. Next one, very important one, Simple Storage Service is a highly scalable, secure, and durable object storage. It allows to store and retrieve any amount of data at any time from anywhere on the web. S3 is designed for a wide range of storage needs, including backups, data archiving, content delivery, big data analytics, and more. And remarkable to say that it's very reliable service. It's provide 99% and 9 nines more of data durability by automatically replicating your data across multiple physical locations within Amazon Web Service region. Next one, Amazon Lambda is a serverless computing service provided by Amazon. It allows developers to run code without provisioning or managing servers. Amazon Lambda automatically scales your application by running code in response to different events, such as HTTP requests, file uploads to S3, database updates. So it runs the code on different triggered events. And the last in the list, Amazon CloudFront is a fast, secure, and highly scalable content delivery network. It helps deliver content such as web pages, images, videos, and different other content to users with low latency and high transfer speeds by distributing the content across a global network of data centers known as edge locations. So it was about Amazon. Next one, the second in our list is Microsoft Azure, which is its second most popular platform. It powers over 95% of Fortune 550 companies. It's a special rating formed by revenue amount of companies. And Azure offers more than 200 products. Top services here, Azure Virtual Machines, Similar as Amazon Elastic Cloud, it provides computing powers for different needs. Azure Blob Storage is an object storage solution designed for storing large amount of unstructured data, such as text, binary data, images, videos, etc. It's highly scalable, secure, and cost-effective, making it ideal for applications that need to store massive data sets that don't follow a specific schema, like documents, logs, or media files. Azure Kubernetes Service is a fully managed container orchestration service which simplifies deploying, managing, and scaling containerized applications using Kubernetes, an open source platform designed for automating deployment, scaling, and operation of containers. AKS allows you to run Kubernetes clusters without the complexity of manual setup, maintenance, or management. Azure Functions, similar to Amazon Lambda, service which provides serverless computing for the customers. And the next one, Azure Active Directory. This is a Microsoft cloud-based identity and access management service. It provides authentication and authorization for users, devices, and applications, enabling secure access to resources, both in the cloud on premises. Azure Active Directory is widely used by organizations to manage access to Microsoft services, Azure services, and thousands of third-party applications. And the last one in our list, Google Cloud Platform. It serves millions of users worldwide, powers Google products like Gmail, Search, has more than 150 products. Top services here, Google Compute Engine, similar to Amazon Elastic Cloud, computer power for your needs. Google Cloud Storage, similar to Azure Blob Storage, provides secured object storage service that's designed to store and retrieve unstructured data. Google BigQuery is a fully managed serverless and highly scalable data warehouse that's designed to perform fast SQL queries on large data sets. It's optimized for real-time analytics and can handle terabytes to petabytes of data, making it ideal for organizations that need to process and analyze massive amounts of data quickly and efficiently. Google Kubernetes, same as Azure Kubernetes, service to handle your containerized applications. And also Google Cloud Platform offers a comprehensive suite of artificial intelligence and machine learning services designed to help developers, data scientists, and organizations to build, train, deploy, and manage machine learning models and AI-driven decisions. These services range from fully managed, easy-to-use APIs to highly customizable tools for advanced users, empowering business to integrate artificial intelligence into their products and workflows. So as you can see, cloud platforms nowadays provides a big variety of service and tools you can use to build your projects and focus more on what's important. So let's talk about one of the offer from cloud providers, which can save some money and maybe bring your project more efficient development. So let's talk about serverless computing. Serverless computing is a method of obtaining on-demand backend. So users run their code on demand, and users only pay for the compute resources they use while executing code rather than managing servers or infrastructure. The key difference from traditional server-based computing is that developers don't need to manually manage server configurations, scaling, or uptime. This all handled by the cloud provider. And there are some benefits of serverless computing. First, scalability. Applications automatically adjust to changing workloads, scaling up or down as needed without manual intervention. So it's very useful for the service which has different traffic spikes and periods where the traffic is low. So serverless computing can help you automate the process of scaling your application. Second benefit is cost effectiveness. You will be billed based on actual usage. Again, it's very cost efficient solution for wearable workloads. When you have low or high traffic, it will bill only for actual use instead of maintaining the servers of certain size in the clouds. And the last one here, performance. Serverless platforms and services offer tools to monitor and optimize applications performance, ensuring smooth operation to scale. And of course, serverless computing platforms. Here you can see Amazon Lambda, Azure Functions, Google Cloud Services, all these features covered in the modern cloud providers. So let's check how serverless computing and cloud computing has been used in the different areas. First, in our examples is e-commerce. Amazon is running on Amazon Web Services, no doubts here, same company. And Amazon is handling the search and traffic during sales periods and different promotions like Prime Day or Black Friday. This helps ensure the stability of the site and the high level of service for millions of customers during events of high demand. Second one, healthcare. Kaiser Permanente, a major American healthcare provider, use Microsoft Azure. With Azure, they process data from medical devices to provide personalized patient care. This approach helps improve data-driven decision-making for over 12 million patients. And the last one, gaming. Supercell, the developer of popular mobile games such as Clash of Clans, use exclusively Amazon for their infrastructure. They scale servers based on player activity, allowing them to ensure the high quality performance during peak periods and save money during periods of low traffic. Very useful one for them. As you can see, you can leverage benefits of serverless technologies in different areas. And let's talk about what challenges you can meet when you work with cloud technologies. Cloud computing offers numerous benefits, but it also introduces security and compliance challenges. As organizations increasingly migrate to the cloud, they must address concerns related to data privacy, security risks, and regulatory compliance. Some of the key challenges here, it's data security risks like data breaches. Cloud environments can be targets for cyber attacks, such as data breaches where sensitive information can be exposed or stolen. And to address this challenge, cloud platforms provide different security audits for their customers, so they can check resources and make action that needed before they face the situation of actual data breach. They can prevent the risks in this area. Second one, access control and identity management. Employers or third-party services providers with access to cloud system may intentionally or accidentally cause security breaches. So the good practice here to follow the least access practice. So the user could have only access for those resources he actually needs, instead of having some extra wide rules which allow them to sign up in different services. And the third in the list, compliance with the regulations. Organization must comply with various data protection regulations, such as General Data Protection Regulation or Health Insurance Portability and Accountability Acts. Different stuff in different countries. These regulations mandate how sensitive data should be collected, stored, and processed, adding complexity to managing cloud environments. So cloud providers ensure that from their side, all these regulations could be completed. But since you are using a cloud and you share responsibility for processing data within the clouds, you need to think as well about completing this compliance from your side, and you always need to be sure that you follow all regulatory acts during using the cloud. Next one I would like to talk about is vendor lock-in. What is a vendor lock-in? Vendor lock-in is one of the major challenges organization face when adopting cloud computing services. It occurs when a company becomes highly dependent on a single cloud provider's infrastructure, services, or APIs. And it makes it difficult to switch to another provider without significant technical, operational, or financial costs. This dependence can limit organizations' flexibility and control over its IT strategy in the long term. So there are some strategies how you can mitigate the vendor lock-in. One of them is applying cloud agnostic architectures. You can design your applications with a cloud agnostic approach by avoiding deep integrations with the specific provider's proprietary services. For example, instead of using a cloud provider's proprietary database or storage services, organization can choose open source solutions that are compatible across multiple clouds, for example, PostgreSQL for database or Kubernetes for managing the containers. And as we mentioned, Kubernetes, second way you can avoid the vendor lock-in, you can use the containers and microservices for your projects. You can use containers like Docker and orchestration platforms like Kubernetes to build applications that are portable across different cloud environments, since all the platforms, Amazon, Azure, and Google Cloud, they support Docker and containers. So containers package will lock all dependencies it needs within the container, and you can easily port your application across different cloud providers. It will ease you to switch a provider. You can also implement a multi-cloud strategy when you have services in different clouds and you share the workloads between different clouds like Amazon and Azure. You can have your servers in the both clouds. This method is called multi-cloud strategy. And also you can use the hybrid cloud strategy when you have your private cloud, where you store sensitive information, different sensitive computational tasks. And you also have public cloud like Azure or Amazon, where you work more flexible with less sensitive data. These methods will be helpful if you would like to avoid the vendor lock-in. And the last challenge I would like to talk about is cost management. Managing costs in cloud can be complex and challenging, especially as organizations scale and use more services across different environments. While cloud computing promises flexibility, scalability, and pay-as-you-go model, it can also lead to unexpectedly high costs in not properly managed, if they are not properly managed. So the dynamic nature of cloud's resources, along with the multiple pricing models and services, creates several cost management challenges for the business. So the way you can avoid this risk and make it easy for you to come over this challenge, first of all, you can use cost monitoring and optimization tools. Each cloud provider have set of tools which will help you to check how much each of your resources cost. You can use Azure Cost Management, Amazon Cost Explorer. These tools can help monitor resource usage. You can set cost alerts if one of resource consumes a lot of money from your organization. And you can identify like cost budget and stuff like this. Also, good practice here is implement cloud cost governance. You can regularly check the budget of your project, how much money they can consume. You can check the resources which are not in use anymore, and cloud platforms can help you with it. You can set up different alerts, you can set up different rules, how to be notified about these issues. So that was the last challenge I would like to mention, and as you can see, it's important to know about it. We talk about challenges, we talk about mitigation steps you can take to ease your work with the clouds. So let's talk now about trends we can inspect in cloud computing nowadays. First trend is edge computing and the Internet of Things. Combination of edge computing and Internet of Things is transforming industries by enabling devices to process data closer to where is generated, rather than relying on cloud data centers. Internet of Things devices collect vast amount of real-time data, but sending all of this data to centralized cloud servers for processing can result in high latency, increased bandwidth costs, and inefficiencies. Edge computing addresses these challenges by processing data locally at the edge, enabling faster decision-making and reducing the need to transmit all data back to the cloud. This trends allows organization to overcome limitations like network bandwidth constraints, latency issues, and reliability concerns, while still benefiting from the cloud scalability, advanced analytics, and machine learning capabilities for deeper analysis and long-term storage. Next trend I would like to mention, this is machine learning and artificial intelligence integrations. ML and AI are at forefront of innovation in cloud computing nowadays. It's transforming how businesses and organizations use cloud's resources to derive insights and automate processes and enhance decision making. The integration of machine learning and artificial intelligence in cloud platforms has significantly eased access to these technologies for lots of organizations. It allows companies of all sizes to harness the power of the technologies without needing to build complex, costly infrastructure in the house. Also, you can see that nowadays appears different clouds which dedicated to work with the machine learning and artificial intelligence. All cloud platforms support artificial intelligence resources. They also integrate artificial intelligence in their services, helping users to understand more how cloud works, how they can achieve more using their clouds. So it is either work with the cloud and work of organization with artificial intelligence. And the last trend I would like to mention, it's a hybrid and multi-cloud strategy. Hybrid and multi-cloud strategies have become increasingly popular in the cloud computing landscape as organizations seek more flexibility, control, and resilience in how they manage their IT infrastructure. These strategies enable business to take advantage of both public and private clouds and even multiple cloud service providers to optimize workloads, reduce cost, and minimize vendor lock-in. So, as I said, hybrid cloud strategy refers to the combination of both private cloud, where you have private cloud for your daily needs, and public cloud services you have a public cloud and private cloud which work together. This allows business to run workloads across different environments with seamless communication and data sharing between private and public clouds. Hybrid cloud model offers the best of both worlds, the control, security, and compliance of a private cloud for sensitive workloads, and scalability, cost effectiveness, and flexibility of the public clouds for less critical or highly dynamic applications. And multi-cloud strategy involves using services from multiple public cloud providers simultaneously instead of relying on a single vendor. Organizations can distribute their workloads across different platforms. They can mitigate risks that one of the platform can be out for some time. And also you can use different specialized providers for specific needs. For example, Oracle Cloud for databases or IBM Cloud for enterprise services. With multi-cloud, business can avoid vendor lock-in and take advantage of each provider's strengths and improve resilience by distributing their application across multiple environments. So we take a look over, I think, the most important trends, the most visible trends in the cloud computing. Hope you learned something new. We can talk more detailed on each provider specifically because learning more about cloud provider is a special course for multiple hours. And we can't cover it in 30 minutes, but I think we cover the most visible and important things over the clouds and serverless technologies. And thank you for your attention. This is the end of my presentation today.
Thank you.
Thank you, Alexey. We haven't a question. Okay, the next speaker, Artem, please.
Hello, everyone. I need to show the...
Thank you very much, Sergey. They're a great presentation. Maybe question in our chat. No, we haven't. Okay, thank you. Well, we meet the next speaker. It's Ilya. Ilya.
Hi again.
Here. Okay.
Maybe I'll try share